Hello and welcome everyone once again to our third and final lecture on project management. I hope today to address some of the remaining key topics that you'll need in your study of project management. Specifically, we're going to address some of the topics I mentioned in the last lecture. Soon we will be face-to-face in Vietnam, and I'm looking forward to that, and I can help you through any difficulties you may be facing. But in any case, let's jump into the very final lecture, recorded lecture, before we meet face-to-face and see what topics we have remaining. As mentioned last time, we're going to discuss soft skills such as leadership, management, conflict, and negotiation. We will discuss risk, and then we will move from the soft side of project management over to some of the more quantitative topics: risk management, scheduling, and the critical path method. Now I'll say, first of all, the critical path method is complex. You really need to spend some time with it, perhaps more so than we'll spend in this lecture. However, this will be a point of emphasis when I'm with you together. But I should mention that project management really has two major themes. One I refer to as the soft paradigm, and the other is the hard paradigm. The hard paradigm is what most people think of when they think of project management, and that is scheduling methods, quantitative and qualitative risk analysis, the critical path method, the PERT method, Monte Carlo analysis. Many of these topics have arisen from operations management, and now they're applied to project management, and they involve quantitative skill sets. However, since about the 1990s, it's become recognized that soft skills are very important to successful projects. We cannot ignore the role of leadership, management, power and influence, building relationships and networks throughout your company and between your company and others. So it's a significant area for research and improvement of practice. So with that, let's get started with a discussion of leadership, management, the hard and soft paradigm, risk management, scheduling, and the critical path method. Which is the critical path method is an important tool for scheduling. So let's examine some of the core concepts out of the PMBOK, which, as you recall, is a project management body of knowledge. This guideline outlines responsibilities and competencies, capabilities and skills that a project manager must have, including interpersonal skills, skills in managing the project team and communicating with others, and managing stakeholder engagement. Recall that stakeholders are anyone that have an interest in the outcome of the project. That could be project team members, your client, other members of your organization, members of the community. So anyone who's interested in the project one way or another is considered a stakeholder. And to engage with them is more than just sending out reports. You may need meetings, you may have dinner with them, you may bring them in for different discussions, you may interview them. So there's different ways of engaging stakeholders and managing such engagement. Now on to leadership, the ability to inspire confidence and support among the people who are needed to achieve organizational goals. I like this definition simply because it's very difficult to define leadership. And also effective leaders, or leaders out in the world who are known to be effective, use a number of different approaches. So it's very difficult to have one comprehensive definition that works for all. But you can say that they inspire confidence, that's for certain. So we recognize effective leaders when we see them. However, it's very difficult to explain to someone how they can be an effective leader in their own unique way. Now, there's a difference between leadership and management. Leaders versus management. For example, there's an exchange of purpose, a right to say no, joint accountability, absolute honesty. These are themes that are discussed when we compare leadership versus management. What is the purpose of the leader versus a manager? Do you have the right to say no when you're given a job assignment? What accountability do you have? So leaders and management work together, that's true, but there are key differences between them. Notice at the top left hand of each of these diagrams, you see do the right thing and do things right. In my view, this is a good simplified assessment of what the difference is between the leader and the manager. When we say do the right things, that means leaders are responsible for vision, for mission, for strategy, for knowing what the company is going to do or the project is going to do and why it's going to do it. And it, based on that knowledge, chooses some things to do that are better to do than others for the company. For example, Steve Jobs and Apple. Steve Jobs put the company on the path for developing the iPhone. And now the iPhone provides the bulk of Apple's sales. That turned out to be the right thing to do. And that is the responsibility of the leader. The manager, by way of contrast, excels in implementing strategy. It takes direction from the leader, the manager takes direction from the leader, and then implements it in a very efficient way. Okay, so that's why we see a clear distinction between leadership and management. Leaders point the way clearly and explain why. Managers implement that in an efficient way. You see the word administer, for example, maintaining the status quo, striving for control, whereas leaders may be innovative. So not all leaders are good managers, and frequently very good managers are not good leaders. They can implement what's the ideas or innovation of others, but they cannot easily generate new ideas on their own. Okay, so project manager leads by acquiring resources, motivating and building teams. They may fight fires, which means put out distractions or end activities or communication or problems that are dangerous to the project. It could get in the way of success of the project. Okay. Also, leaders are responsible for getting the funding that's required. Okay, so you may hear the term funding. You also may hear the term resources. You may think of resources in terms of people, but people are one form of resource. Equipment is another. Funding is another. So these are aspects of that a project needs in order to survive. It needs people, it needs funding, and these are resources upon which the project can draw in order to succeed. So leaders are responsible for doing this, getting the funding they need, and to build that trust with the managers in the company. Okay, purpose of meetings. What do leaders and managers both do? They have meetings. What are the meetings for? Well, meetings should be goal-oriented, and they should, as one of the goals, increase commitment to the project, and also provide opportunities to discuss the project. Now, I can tell you personally, I don't like meetings very much. Yes, it's a necessary evil. And in my view, sometimes you need to have meetings, but I feel personally that you should only hold a meeting if you have something that's important for the entire team to share. And if you do have such a meeting, you should keep it short and efficient, because people are getting paid and the people who are sitting in the meeting are using up costs. So it better be time and money well spent. That's my personal opinion. Other managers may have different views, but make your meetings count for something. They should be goal-oriented. They should have a purpose. And I feel you should keep them short, sweet, effective. In fact, one approach to meetings is called a standing meeting, where no one sits down. Everyone stands, discusses, you review what needs to be done, and then you go and do it very quickly. Okay? Part of good meetings and good management is communication. There is something called task-oriented behavior, task-oriented and group maintenance behaviors. Task-oriented is about structure, clarification, summarizing, getting consensus. And in fact, it's said that good leaders have a balanced mix between task orientation and group maintenance behaviors. Here we see group maintenance behaviors like harmonizing, supporting, setting standards, analyzing processes. Okay, so you see this often in discussions of leadership. Leadership is a mix of task orientation and group maintenance, or / another way to say this is relationship orientation. In other words, you spend time focusing on the things that need to be done, but you also spend time on people, and those are two different outlooks for the manager. Often project managers are highly task-oriented. They think, I need to do this, I need to do this, I need to do this, step by step, 1, 2, 3. But people are not machines. You have to interact with people. You have to build relationships with others in order to get those things done, because a project manager does not do everything by his or herself. They do things by enlisting the help of others. So this is why task orientation is not enough. There's group maintenance or relationship orientation. That's also important. And this is why we have characteristics of an effective project manager. If you're going to be a project manager, to a certain degree, you're going to be a leader as well. You're going to have to lead by example, visionary, technically competent, decisive. Like when an important decision needs to be made, you will step up and make it, even if the decision is rather ambiguous and it's not clear which way to go. One thing I always tell budding project managers is not making a decision is a decision. If you don't make that decision, things are going to happen anyway, so you might as well have your opportunity to step in and decide how the issue should be dealt with. Technical competence is an important issue with project leaders. When you are technically competent, that means you can have credibility among your team member. This is especially true when you are leading technical teams, which are many teams that I have led have been focused on getting things done or getting technical work accomplished. If you're a project manager leading a team and you're carrying out technical work, but you yourself as project manager do not have technical capability, it will be difficult to get credibility from your team. Now, what's a characteristic or trait of effective project leader? A good project leader has credibility, they solve problems, they have a tolerance for ambiguity. Now, this is something you should consider in a project management career. Things are always changing. Life is not easy for a project manager. There's so much uncertainty. So because of this, you have to learn to live with a high degree of ambiguity in your life, uncertainty. Every day you come to work as a project manager, you're not sure exactly what's going to happen, and you have to be prepared to deal with it. It's exciting, but it's challenging. It's something that you as a project manager will have to learn to live with. All right, let's jump into team building, conflict, and negotiation. And once again, this comes out of the PMBOK as well, where you plan how you're going to manage human resources, you're going to acquire, develop, and manage your team. And there's a process flow associated with many of this and many of these items in the PMBOK. For example, how do you assemble a team? You identify skills. Where does that come from? The work breakdown structure. That's the structured outline of what you will need to deliver. Then you match people to skills. You talk to different team members. You negotiate with the functional supervisor. Recall that a project team operates separately from the ongoing functional operation. So if you're going to acquire someone to join your team, you'll need to negotiate with their supervisor. And then you assemble the team. Then you help develop skills to the extent that you can, keeping in mind that a lot of the work for skill development must happen between projects, because during a project you're getting the work done and there may not be significant time for developing skills if you don't already have them. What are characteristics of effective teams? They know where they're going. That's a clear sense of mission. Why are we doing this? They rely on each other. They work together well with cohesiveness. They trust each other. They're passionate. They're excited about their jobs, and they want to produce results. On the other hand, teams could fail if the goals are not clear, if they don't define how each of the roles work together with other roles, if they're not motivated, if they have poor leadership. If you examined each of these reasons for why teams fail, you could see clearly why a leader could make a big impact here. Leaders can help establish the need for, or clarify the goal. They can help build excitement and passion in their team. And a poor leader is not able to do that. So this is why failed teams are often associated with poor leaders. Now, you have already discussed this in some of your assignments that you've been working on, and that's the stages of group development. The 5 stages: forming, storming, norming, performing, and adjourning. And you see at the bottom, the punctuated equilibrium model is a different model. So this is something for you to think about. What these stages suggest is that teams do not become effective all at once. There's a process in becoming a team. All the team members come together, they get to know each other. Then as they work through uncertainties in the different roles and understanding who's going to do what and how they're going to get the work done, there may be some conflict. Norming is another way of saying rules, processes, procedures, some structure starts to evolve in the team, and the team members start to understand each other better, and they begin to work together based upon the rules, policies, procedures, whether explicit or implicit, as they work together, and that's known as norming. And then once this happens, the team really begins to produce, and then finally the group disbands. The punctuated equilibrium model is a different model. And what this model says is that the team performance is rather low in the early stages, and then they get to a point when they realize they're running out of time, and due to time pressures, suddenly they realize they need to put their differences aside. The performance jumps up in kind of a step function, and then productivity, performance improves from there. So I'll leave it to you to decide which of these models best reflects reality. In reality, all ideas about team stages are simply models. Reality is, they're only going to reflect reality in an imperfect way. So you could see here an example of the team development stages, where you have forming, storming, norming, performing. And as I tried to describe with my hand just a minute ago, the project timeline and the punctuated equilibrium model, that what this really says is this forming and storming really stays in place until about the midpoint, when time pressures cause the team to suddenly start working together very well. And this is when performance dramatically improves. And it's called punctuated equilibrium because of this big pop in the middle. It says eruption. There's a big step function in output in the team. Cross-functional. What does this mean? Well, if you are a general manager of the company, all of the functions of the company report to you. Okay, so if all the functions report to you, then as a general manager, you have cross-functional authority. But the problem with that is if you're the only point in the company where all the functions come together for a common purpose, then that means below your level there may be limited opportunities for interaction between the functions. And when I say functions, I'm talking about the different divisions of labor within the company. For example, engineering, manufacturing, service, finance, accounting, all of the different functions that are separated. They may not talk together very well, except when they get to the higher levels of the company underneath the general manager. Well, a project team is really designed to include people from the different functions, and so this is a good way to get cross-functional cooperation and also a total holistic company-wide view of what you're doing by incorporating different functions. Now, one challenge you're going to have as a project manager these days is the fact that many project teams are virtual. Project team members exist all around the world. They may interact via YouTube, Skype, Adobe Connect, email. So face-to-face communication may not always be possible. So you have to replace face-to-face interaction with process. Clear policies, procedures, rules of how you're going to work together, how often what are you going to do, how you're going to standardize on conduct and output. It's a challenge, but then again, most all companies these days do involve a certain amount of virtual teamwork. So it is becoming something really serious in the information age in which we live. These days, you can get on a plane from anywhere in the world and travel to anywhere else in the world within maybe a day, and you can instantaneously communicate via voice communications, Skype, So these technologies do enable virtual teams to work much better, and this is why we see them proliferating around the world. I can't think of a single company that doesn't use virtual teams. But it will only work well if you manage it well, and that's your challenge as a project manager. Okay, conflict. There's a few things to think about when it comes to conflict and resolving conflict. Every team member will have different ideas about how to do things, how to approach doing work, the strategy your project is going to employ in producing deliverables. This is quite common. So your challenge as a project manager is to consider how much conflict will you tolerate in your team, and when conflict is present, how will you resolve it? All right, so notice in this definition from the text that conflict also involves frustration, and there's different categories of conflict and views on conflict and sources of conflict, like organizational and interpersonal. And then there's resolution of conflict, ways to consider how to address conflict, maybe to reduce it. I will tell you my view on conflict. Conflict is inevitable, and personally I think a certain amount of conflict is healthy, especially when it comes to strategies about getting work done. Especially when you have technical people on your team, you may find fierce disagreement on how to get certain things done. This is quite common, and actually it's good to have this type of conflict, because then it will force you to think very carefully about what you're doing, and maybe your final decision will be much stronger than if you just made a simple decision without scratching the surface. Conflict does go below a surface acceptance of solutions. This is why conflict takes longer. It takes longer to make decisions, and it can be more painful to make decisions, but in the end they're often stronger. Okay, so that's the good point about conflict, and that's healthy, in my view, for a project team. Conflict that's not so good for a project team might be conflict that's personal, and let's go back and revisit some of these sources. For example, personal grudges and prejudice, faulty attributions where you think ill of someone else, or improper communication, which can always happen in a global setting. These are elements of conflict that are really unhealthy for the team, and you should avoid this. So, as a project manager, what does it mean for you? Keep your team focused on the goal. Keep personalities and personal issues out of the project team. And do what I've always recommended for any manager, and that is to be fair, firm, and fast, and speak with clarity and have passion about the goals, to get petty personal issues out of the way. This will go a long way toward resolving unhealthy conflict, but then keep the healthy conflict in place to help you with stronger decisions. One way to resolve conflict is to negotiate. Now, this may happen within your team. It may happen outside your team as you're trying to acquire resources for your project team. But negotiation is really about trading. You have something that the other side may want, the other side may have something that they want, and you trade back and forth. And how much you gain from a negotiation depends on your influence, depends on your power, and what sort of time you have, how much trust. But there's some basic principles to think about in negotiation. And this comes from the Harvard Business School negotiation book. It's by Urey and Fisher, and it's called Getting to Yes. And this is separate the people from the problems. Focus on interests, not positions. Seek mutual gain and insist on objective criteria. This is good advice. And one of the reasons for example, to separate people from the problem is sometimes people in a negotiation may talk with a loud voice and bang on the table and shout. And it may be very upsetting, and you may get angry with that other individual. Well, try not to think about the individual. Try to understand the underlying problem. Also, try to think about what underlying interests the other side may have. For example, some person you're negotiating with on the other side of the table may be asking for an unreasonable amount of compensation. However, that is only a position, and that position may not be realistic. So don't get angry about that position. Try to imagine what their underlying interest might be, and this may help you come to some better solutions in your negotiation. It's also important that both sides have some element where they can win. For example, if I have something that you value more than I do, and you have something that I value more than you do, if we trade, we both win. That's far superior than a type of negotiation where only one side wins. When that happens, it's very difficult to maintain a relationship, and you may not even come to a negotiated settlement when you do that. And you have to have objective criteria. Think in terms of numbers. Think of some reference standard you can both agree on, and that will help you come to conclusions. Remember, finally, that negotiation is about trading things. You have things you value, the other side has things that they value. When you trade one for the other, it's a win for both sides, and that's good negotiation. So let's shift now to our next topic, and that's risk. Let me tell you, first of all, what I think about risk. In my view, a project manager is really a risk manager, in the same way that an airplane pilot is a risk manager. A pilot flying on my flight from the U.S. to Vietnam, there will probably be many hours during that flight where the pilot has very little to do. But the pilot is there just in case something terrible happens. The pilot makes sure the flight is on course. It helps dodge bad headwinds and thunderstorms, and makes the plane land safely. So the pilot becomes very important at critical times. Likewise with the project manager. There may be times when things are going well, but the project manager really gets involved when things are not going well. So I'm thinking in terms of risk, as defining risk as anything that stands in the way of project success. If you think of that definition, risk is anything that stands in the way of project success, well, then a project manager is a risk manager, because all day long a project manager will seek to push aside anything that stands away from project success. Now, you may have also heard that phrase, no risk, no reward. Well, here you see an example of this. Without risk, if it were true that nothing ever stood in the way of project success, this would imply that projects would just happen. Everything works out well. Well, if everything works out well, there's no opportunities for project managers, and no opportunities for project managers to earn a reward by getting paid a salary or bonus or something like that. So because there is the risk that so many issues will intervene to stand in the way of project success, now because there is risk, there is the opportunity for reward, for the project manager to step in and push aside those elements of risk that stand in the way of project success. What does the PMBOK say about this? Well, when you're managing risk, you plan, you think about how you're going to address risk, you identify them, you perform qualitative and then quantitative analysis, and consider how you're going to respond to risk once you've identified them. And then you control risk, the risks that become issues, and this is something to think about, that when a risk has become visible, it's no longer a risk, it's actually an issue. But when a risk has become an issue, you have to control it. You also have to control your plan for responding to risk. So some things you should consider in risk management. What could happen? What's the likelihood? That's the probability and the impact. For example, if the probability of something happen is 10%, and the impact, if it does happen, is $100, then the probability times the impact is 0.1 times 100. So the overall impact is, you could rate that as a $10 risk, for example. If you can quantify probability and the impact, then you can consider what should you do to minimize the probability or impact. Okay, what cues? This means what will trigger the action. In other words, if you recognize a risk and you recognize there's a probability for such a risk, and you have a plan to address that risk, what trigger will cause you to start that risk response plan? And then what are the likely outcomes of your anticipated reaction, the outcomes of the problems? Okay, risk management is the art and science of identifying, analyzing, and responding to risk factors throughout the life of a project. You may have an uncertain event, a condition, and here's one thing you should think about. Risk can be positive or negative. And you may think, how can a risk ever be positive? That's a good question, because I rarely encounter positive risk. I've rarely encountered it in my career. But a positive risk is something that could happen that could cause a much better situation than you intended. Here's a good example of this. Maybe 10 or 15 years ago in the US, maybe around the world, Nintendo introduced the new Wii game, Nintendo Wii. It was new at the time, but when that project released the product and the product was introduced, there was not enough inventory. Why wasn't there enough inventory? Because there was far greater acceptance of that product than was anticipated in the marketplace. So suddenly all the product is sold out, and Nintendo was not able to supply that product to the market. So this is an example of a positive risk. And Nintendo could have asked themselves, what happens if the sales of this product are far beyond what we previously imagined? How would we deal with this? Okay, so they could have had a plan to ramp up their inventory much more quicker should there be unexpected positive acceptance of their product. That's a positive risk. Again, for me, I rarely experience positive risk, usually negative ones. But in any case, that's something you have to think about as a project manager. Now notice that in the project life cycle, notice what happens to risk. Notice that risk tends to decrease as the project continues. And the reason is, as the project continues, you know more and more, and you've gone through a number of management efforts to minimize risk and produce your deliverables. So risk tends to be very high at the beginning, and it declines at the very end. And of course, once you've delivered your project, it's going to be close to zero. But there's very high impact toward the end of your project, and the reason is, at that point, it can be very expensive to address risk. A classic example, when I worked at Panasonic, we were 3/4 of the way through a project, maybe almost at this point where you see period of highest impact. We were making a cellular phone handset, and this was before the iPhone came out. This was maybe 1999, year 2000, many years ago. And at that time, most phones did not have a color screen, and they were just being introduced to the market in the US. So our boss goes to the Consumer Electronics Show in Las Vegas, sees many phones with a color screen, comes back and tells us we need to change our design to have a color screen. Well, it happened during this period of highest impact between execute and finish. So it required a major redesign that was almost impossible to do. So this is a risk of a sudden shift in the market happening when you're least able to address it. So identifying that up front and then addressing it early is far preferred than addressing it later when it's more expensive to address. Now let's look at stages of risk management. Typically, you think in terms of identifying risk, analyzing risk, risk mitigation strategies, and risk control. So mitigation means to reduce a risk, to make it less than it otherwise would be. Well, that's fine, but that is not the only type of risk or type of strategy for addressing risk. Mitigation reduces risk, but there are other ways to address risk. There are other ways to address risk, and how I think of it is using as a memory device. I think of the Metropolitan Atlanta Rapid Transit Authority, or MARTA. So when you think about risk and how you will respond to risk, you can mitigate, which is to try to reduce the risk. You could avoid the risk by not engaging in a particular element of a project where you would encounter such a risk. You can mitigate, you could avoid. Okay, so notice avoidance is one strategy in addition to mitigation. You can retain the risk, which means you're going to just accept the risk is there and address it once it arises, or you could transfer the risk. And a common way of transferring risk is to use insurance. For example, if you drive a car, typically you have insurance in your car, for your car, and that's a way of transferring risk to others, and you're compensating others to take on that risk you normally would have. Now, some of that risk is retained. For example, most insurance has a deductible. If you have a deductible, that's an element of risk that's retained. So just think of MARTA: mitigate, avoid, retain, and transfer. One way to assist you with identifying risk is to use something known as a risk breakdown structure. You hear the term breakdown structure quite a bit in project management. This is just a structured outline to help you think about the different types of risk, general categories of risk that your project may encounter. You have internal and external risk. Your internal risk could be technical or organizational. Your external risk could be market or environment, and so on. This is a way of systematically examining major categories of risk that your project is likely to encounter. And then once you've addressed them and you've identified them, you can use analysis methods to determine the probability and impact of such a risk arising and becoming an issue. And once you've done that, then you can consider how to address the risk in terms of your responses, meaning MARTA: mitigate, accept, retain, and transfer. Mitigate, avoid, retain, and transfer. Once you have identified risk using the risk breakdown structure and quantified their probability and impact, you can use a risk impact matrix. The risk impact matrix helps you see at a glance which risk have the highest impact or consequences and the highest probability of occurring. So those in the upper right-hand quadrant, which would be high, those are risks that you should monitor very carefully in your project. Other risks outside of the high quadrant you may monitor, but not as closely as the most high ones, because if they do happen, you will have severe cost associated with it. All right, so that is an overview of risk. And again, you're examining the probability, the impact, and just to keep it very simple and make it very easy to understand, most of the problem with project risk is that the things that tend to happen in a project that are bad, we often don't think about. So much of what you see in the PMBOK is designed to help project managers identify risk that they otherwise may not have noticed or may not have thought about, because it is always those things you don't think about that end up being dangerous for a project. Okay, let's examine our final topic today, and that's project scheduling. Project scheduling and planning, you're taking the things you are going to do in the project and putting them in order. And notice in the text, it refers to linked activities with planned dates, durations, milestones, resources. These are the list of activities you are going to do in order to produce the deliverables, the order in which the activities follow, how they're connected to each other, and what target dates are you trying to achieve. For example, here's a serial sequential logic flow. It's a series of activities that happen one after another. For example, a research paper or presentation. You identify the topic, you research the topic. You do a first draft of the paper, you edit, you prepare, etc. The key for option A and sequential logic are things happen one after another. For example, brewing coffee. When you brew coffee, you must put coffee grounds in the filter and put the filter in the pot. Then you must pour water. Then you must brew. So one thing after another. Those are sequential. That's sequential logic, and you will see this. But not all projects are purely sequential. There are things that can happen in parallel. So if we examine option A more closely, You can edit the paper and prepare your presentation at the same time, and finish your presentation while you're working on the final draft of your paper. So you can see things can be done in parallel with each other. The same with making coffee. While the coffee is brewing, you can go get cream, sugar, get your cup, get your spoon, etc. Okay, so let's take a look at the different types of networks that can be used. You will see in your text something called AOA versus AON, activity on ARC and activity on Node. In most cases, be it project management software, be it manual project networks that you work on, and I'll help you work on when I'm in Vietnam with you, we will use the activity on Node. This is the most common way to do things. Activity on ARC, or activity on Arrow, as it's sometimes called. You may see activity on Arrow networks in some textbooks, but they're only used for a very specialized purpose, and they're often difficult to understand and work with intuitively, which is why most project management software, project management text use the activity on Node. Microsoft Project, Project Libre, these are software packages that use activity on Node, and when you do it manually, you use that as well. Each node is typically a box where you can put the early start, the late start. Some of these terms seem a little bit difficult to understand, but we will discuss them in more detail when we're together. For example, let's go back to the making coffee example. All right, so let's say it takes 5 minutes to brew the coffee. Well, when I'm brewing the coffee, I can get my cup, my spoon, my cream, my sugar, all in parallel with brewing coffee. Okay, so what's the latest I can start without delaying my cup of coffee? Well, if it takes 5 minutes to brew, I could probably wait 4 minutes and 45 seconds before I get my cup. Then I'll have 15 seconds left for the coffee to finish, and I could pour it. So that's what's meant by late start or late finish. When you have more than one activity and they're in parallel, you could decide to start an activity later than you may otherwise see. So that's an example of concurrent activities. And here's how you would put it in the box view. Concurrent activities versus serial, sequential activities. Put an activity on node format, and then you see merge activities when you have multiple activities being terminated into one, or a burst activity. When one activity is finished, many other activities follow. So merge and burst are just a way to discuss the order of events and the connectivity of different events. A complete network will typically have a mix of both merge and burst activities. For example, contract item A in this network is a burst activity because B and C follows it. However, D is a merge activity because B and C enters. Or H is a merge activity because E, F, and G are activities that precede it. So this is just a term used to identify different types or different phenomena you will see in a project network. Okay, let's discuss how you would determine the critical path. Now I'm going to warn you, you might be scratching your head a little bit thinking, what is this critical path all about? Well, when you have a series of activities, one following another, and also some activities in parallel, it's not immediately obvious how long the project is going to take. What you have to do is a series of steps to understand what is the longest path in that project network. The longest path is the shortest possible time in which you can complete the project. And that path is known as the critical path. So really, to find the duration of your project network, you need to find the critical path. And this is done by conducting a forward pass, a backward pass, and then once that is done, you determine the critical path. Okay, let's take a simple example. Here is an initial project activity network with task durations. This is activity on node because each node is where the activities are. Each of the nodes are labeled, and we see there are durations. Let's just say this is days. Like contract is 5 days, design is 5 days, market is 6 days. So the reason we need to do a critical path is because by quick inspection, it's difficult to see what is the total time it takes to deliver this or to produce this network or produce this project. And the reason is there's multiple paths. For example, is the time to complete this the top path A, B, E, and H? For example, 5 plus 5 plus 6 plus 2, which would be 18. Or is it A, B, D, F, H, which is 5 plus 5 plus 13 plus 4 plus 2? Or is it 5 plus 6 plus 13 plus 4 plus 2? Or 5 plus 6 plus 9 plus 2? Which is it? It's not immediately obvious, and this is why the critical path method using the forward and backward pass helps us to understand this. Now, before I jump into this, and again, we will work several of these when we're together so you can see in more detail how this works. Okay, so don't be scared off by this. There's also some good news that whenever you use project management software, it does this for you automatically. But you should understand what it's doing. So here's the problem we face. We have a series of activities. Some are sequential, some are in parallel, and by inspection, we do not know, it's not immediately obvious how long this project will take because there are multiple paths. So the first thing we do is the forward pass. What you do is start at the upper left-hand corner of each activity. Okay, let's start with A. Start the first activity. When's the earliest you can start A? Well, you started at time 0 because this is the very beginning. The duration of A is 5. So the finish time for A is 5. You start at 0, you take 5 days, you finish in 5 days. Now 5 is connected to both B and C. Okay? So when you have an activity connected to a preceding activity, the finish of that activity becomes the start of the next one. So A finishes at 5, so now B and C begin at 5. Okay, so B has a duration of 5, so starting at 5 plus 5, B ends at 10 days. C starts at 5, takes a duration of 6, and it ends at 11 days. So now we have our first element of complexity here. We have B finishing at 10 days, C finishing at 11 days. Well, when should D start, since B and C are both connected to D? Okay, that's a good question. Here's how you think about this. Since B and C are both connected to D, this suggests that you cannot start D until both B and C are finished. D can't start any earlier than that. So if D has to wait until both B and C are finished, by when should it wait? Well, B and C are both finished only at the duration of 11. So this is why the 11 moves forward to D, simply because D cannot start until B and C are finished. And that only happens at time 11. At time 10, B is finished, but not C, so you still can't start D. But at time 11, both B and C are complete, so then you can start D. Okay? Now, if we go to the top path again, we see a B connects to E. So you move over your finish date at the top right-hand corner, and you start E with 10, add 6, and now you have 16. Okay, so that seems pretty reasonable and clear. D begins at 11, as we just mentioned, has a duration of 13, and 13 and 11 is 24, so D ends at 24. And F is directly connected to 24, so now 24 plus 4 is 28. That's straightforward. C is connected directly to G, so C ends at 11, G begins at 11, you add 9, that's 20. Now we have the same problem at H that we did at D. We have E, F, and G, all three feeding into H as a merge activity. So which duration does H start? Remember that the way I explained this to you, H cannot begin until all three, E, F, and G, are complete. Well, when is that? That's at the longest possible time. That's time duration 28. Because anything earlier than that, F is still not finished. Okay, H cannot start until all three are finished, and that can only happen at the longest time of all three, which is time 28. So H begins at 28, it has a duration of 2, and it ends at 30. Okay, so now we have an idea of how long the project takes, but we still need to do something called the backward pass to identify which path in the project is the longest in the project. And that would be the longest path is the one that has, and you'll see this in textbook, 0 slack. That means if the activity itself is delayed, the overall project is delayed. That the early start is the same as the late start. There's no room to maneuver for all activities that have 0 slack. That's what the backward pass finds. The forward pass tells you the overall duration of the project schedule. Now we got to find the critical path. And to do this, we ended with 30. We moved 30 to the bottom right-hand corner of the presentation box, H, and we start moving backwards by subtracting. So let's take a look at this. So 30 drops down to the bottom right corner. Subtract 2 from 30, you have 28. H connects to E, F, and G. So, and again, we're going from right to left this time. So because of this direct connection, 28 occupies the lower right-hand corner. Okay, so now we subtract the duration of each of these. And just to refer back, okay, so let's once again remember the node labels, early start and late start. If you subtract one from the other, whatever remains in the middle is your float or slack. If that is 0, that means you have no room to move. If it's 0, there's no difference between early and late start. This means if you do try to move that activity, the overall schedule will be delayed because the early start is the late start and there's no room to maneuver. Okay, so let's go back to the backward pass, and we will examine in the backward pass every activity that has no slack. For example, A, if you subtract 0 from 0, your answer is 0. This means you cannot move activity A without delaying the overall project. Now, activity B, if you subtract 6 from 5, you get 1. This means you can move B by delaying it by 1 period of time or 1 day, and it will not delay the schedule because you have 1 day of slack. C, if you subtract 5 from 5, you have no slack, so you cannot delay that activity without delaying the overall project. So what are we left with? A, C, D, F, H are all activities that if you subtract the early start or the late start from the early start, you get a value of 0. So A, C, D, F, H cannot be moved without delaying the overall schedule. Now, B can be moved because it has a slack of 1 day. E can be moved because it's got a slack of 12 days. G can be moved because it has the slack of 8 days. So all of these activities are important. And I've had some students ask me, wait a minute, all these activities are important. Why do you just list some activities as critical and others as not? Well, they're only called critical because of the critical path, and that is a narrow definition, meaning that if you delay any activity on the critical path, the overall schedule will be delayed. The other activities, those not on the critical path, doesn't mean they're not important. It just means that if they're delayed, they won't delay the overall schedule. So here's an example now of all of this completed. Okay, and this is a good reference slide. You have every activity. You've subtracted late start from early start. You've identified every one of these items that has a 0 in it, and you can see the heavy, the bolded line, and you see A, C, D, F, H, that's the critical path, and none of those activities may be delayed without delaying the overall schedule. Okay, I'll give you one other example as we wrap up this, and this is from another text, but this is typical of what types of projects you may see in the modern world. Here's an county engineer design department where you've got activities A through H. They're described. You list the preceding activities. Remember, preceding just means that which comes before, and you have the activity times. So here's an activity on node network. We know it's activity on node because you see these boxes where all the important information is placed, and you see arrows between them. Notice you have the label in the center, the duration on the bottom, and we're following the convention of early start on the top left-hand corner, late start, the bottom left-hand corner, the slack in the middle, and the description. So once again, we have a network diagram that's not really clear exactly how long it's going to take, because we have some activities in sequence and some in parallel. We don't know if the critical path is, ACFGH, ABFGH, ACEH, ADFGH. We don't know by inspection. So we have to use the forward and backward pass algorithm. And again, Microsoft Project does this automatically, but now you can know what that software is doing. And again, in the case of Microsoft Project, all you need to do is enter in activities, enter in durations, enter in predecessors, and that's sufficient for it to calculate the critical path, which tells you all those activities that cannot be moved without delaying the schedule, and it gives you the duration. So again, what's the first step in the activity on node network forward pass? We start at the upper left-hand corner, beginning with the first activity, and go from left to right. On A, 0 plus 5 is 5. And we start, the early start of B, C, and D is the same as the early finish of A. Okay, we calculate again. 5 plus 15 is 20, 5 plus 10 is 15, 5 plus 5 is 10. We have that dilemma that we noticed before. When can F start? Activity F can only start when B, C, and D have all finished. When is that? During the longest time, which is B. 20 units of time, so that's when F can start. You have to ask the same question for activity E. When can E start? Only when both C and B have finished, and that's at units of time of 20. All right, and we have the same dilemma again at H. When can H start? Only when both E and G are finished, so that's at time 200. So that's the forward pass. We have taken every duration. We have moved over durations to sequential activities. We have added the duration for each activity, and here's the rules. ES, early start plus duration equals early finish. Okay, now we're going to do a backward pass. We start at the bottom, 235, subtract 35, we have 200, we move that over. G feeds directly into F. Okay, F, now when feeding into B, you have F feeding into B and E feeding into B. But remember, when you're going the backward pass, you take the smaller value, not the larger. So the early finish, or the late finish for B is 20. Okay, and same with C and same with D. You also have the same issue with B, C, and D feeding into A. You take the smallest number. Okay, and once you do that, we know that the A late finish is 5. What do we get when we finish? We subtract out the late start from early start and find out every activity that has a 0 in the center. Okay, once we do that, we will have identified the critical path. That's the longest path in the project, and it's also the shortest possible time in which the project can be completed. And it also, because each of these activities have 0 slack, that tells you you cannot move, you cannot delay any of these activities without delaying the overall project. So that's the essence of scheduling and the critical path method. Once we're together, we will do a few more of those in detail to give you some practice with it. We will also do something called PERT, which uses the same principle as the forward and backward pass of the critical path method, but it also involves some statistics. So it really takes a little bit more time than we have today from all the different topics that we have to discuss. But don't be afraid of statistics. I will explain that to you when we're together, and we'll get some practice with both the critical path method as well as PERT, the Program Evaluation and Review Technique. So today, just to wrap up, what did we discuss? We discussed leadership, management, conflict. We also discussed the difference between leadership and management. We explained what negotiation is. It's a process of trading something you value less for something you value more, and when both sides have that opportunity, it's a win for both. We discussed risk, where you identify risk, you analyze risk, you do qualitative and quantitative risk analysis, typically by probability and impact. Then you consider, once you identify what your risks are, you consider how you will respond by mitigate, avoid, retain, or transfer. All right? Those are the... And finally, I should mention in risk management, once again, that a project manager is really a risk manager if we define risk as everything that gets in the way of project success. Then finally, although this is many topics to cover at once, which is why we will do it in more detail in Vietnam, we discuss some of the principles of scheduling. By now, you should know what is a network diagram, difference of series and parallel paths, what's important, why do you need to do a network diagram, so you can find out what the overall duration of the project is, and further the identification of the critical path and why that's necessary. Because in managing that project, you need to know what's the longest path in the project, which is the overall duration of the project. You also need to know all of those activities which cannot be moved without delaying the overall schedule. And those are all the activities on the critical path. And once again, it doesn't mean that other activities are less important. It's just that other activities can be moved to some degree without delaying the overall project. And to what degree can you delay them? By the amount of slack in each activity. So that's an overview of some key topics. This has been Lecture 3, an MBA6961. I look forward to seeing you all again in Vietnam, where we'll go through these topics in more detail and prepare for the exam. I wish you well in your studies, and please reach out if I can assist in any way. Thanks, and see you soon.